All right. So we're aiming to get the practice test done by tomorrow. All right, by tomorrow. All right. So I'll come around and check those in a little bit. Today, well, I think we should get through the rest of the multiple choice today. All I'm going to ask you guys to do, it gets kind of tedious. Trust me. I go over it twice a day. All right. These questions they can be challenging. They can be kind of conceptual at times. They're tedious. I know we've been going over for multiple days in a row. Your job is, again, to take good notes, to focus, to ask questions, to try to pick up on things you missed. All right? Please focus. Let's not waste this time going over this stuff. Wednesday, I am in the building, but in meetings all day, so I will not be in this classroom. And so you're going to be doing 5-1 through a video lesson. I apologize. But we'll do 5-1 and then 5-2 for a couple of days. That'll get us through the end of the week. I would like to have some sort of quiz coming up just on, giving you guys some opportunity to revisit some of this stuff we've been testing on. Nothing too challenging, more of like when I say review, I haven't made it yet, so I want to give you guys some of the points. We've been going a while without some of the points. So I want to give you some opportunity to get points. Whether that is going to be, it's probably going to be some derivative rule practice, maybe some product rules, chain rules, along with some trig, inverse trig log, just basic derivative rule practice. We're going to need to be pretty proficient in that as we go into the second semester. So look for that late this week, early next week, just an opportunity, even if it's not like a dedicated day, might be like a half a period, but something to kind of mix in some summoning points there. All right, so calculators out, if you got them. As that's loading, number 82 was only a 26% correct. The class, definitely talk about it. We're looking for a maximum value of f. So f this one was assigned, right? Do you know why you missed this one? Did you use your calculator? What did you look for? Do you remember this one? You're graphing which function? F prime. So what should you be looking for? For a maximum, F prime needs to have a critical point 0, an intercept, and F prime needs to, at that intercept, change from positive to negative. Do you agree? A positive to negative F prime change would allow F to change from increasing to decreasing, therefore yield a maximum value. Are you okay with what we're looking for? All right. So I'm going to graph that function. Do you guys have it written down? Does anybody have it written down? That'll save me some time. So once I go to type it in, if you could read it off to me, that would be awesome. Oh, let me ask you this. Did you guys solve this in the graphing window or in the calculator window? I would do graphing because you can visually look. Remember how I said the visual first derivative test comes up a lot in this test? I've said that a few times already, haven't I? Here's another instance, all right? It's the square root of, wasn't it x to the fourth? Yes? Plus 1? Anything else inside the square root?
No.
All right, then outside?
Plus x to the minus 3x.
That's it?
Yeah.
Thank you. All right, so there is, what graph's that again? That's f prime, isn't it? We're looking for f prime to change from positive to negative. How many times do you see that happening here? Once. Here's f prime. F prime changes from negative to positive. That would be a minimum. Positive to negative, that would be a negative to positive minimum. So we actually want to find that value. Menu, trace, graph trace. There's other ways to do this. All right, I'm getting 0.350. All right, you could also do menu, analyze graph, 0, click before it, click after it, and it'll give you that value. And that's another way to do it if you want to just calculate a 0. You don't only want to trace. Tracing is nice because you could find the 0. You can also find the values. If you type in an x value and hit enter, it'll spit out a y value. So 0.35 is my critical point. Listen carefully. This is where I go to the test and I say x, critical point, x equals 0.350. That was a critical point. Did it become a maximum value? Yes. F prime changed from positive to negative. Are they asking me for the x value or the maximum value, which would be the y? X equals, right? So 0.350 was 82 letter C. Yep. I'm just curious. What did you guys, a lot of you answered A. Can you tell, no, wait a minute. Answered B. Can you tell me what happened there? Oh, you looked at the maximum on that graph, didn't you? Okay. Please be honest. Don't you think that's something you would not miss again? Like me telling you, oh, you're looking at f prime. Be careful which graph you're looking at. Would you agree with that? That's another point right there. Okay, 1.2 actually. Every multiple choice is 1.2 points. Okay, so that is one I think you guys could get next time. All right, next one. 84 was kind of rough. Another one of these. Man. All right, from negative 1.5 to 1.5, let the function with first derivative be given by that ugly thing. And I warned you guys. I said this test is full of E's and LNs and ugly stuff. All right, which of the following are all intervals on which the graph of f is concave down? I think it's a good habit to still stack these like we've been practicing all year. F prime, F double prime. Aren't I looking for where, if f is going to be concave down, isn't that when f double primes are what? Negative, right? Because your f primes were, watch up here, your f primes were this, and then your f primes were decreasing, causing it to curve down, concave down, right? Remember that? What about this? The slopes are decreasing, curving down, concave down. The slopes were, the f primes were decreasing. All three of these go together. They happen concurrently, all right? When your f double primes are negative, your f primes are decreasing, which causes f to be concave down. And since we're looking for that scenario, we are looking for where this graph, we're going to graph f prime. We could graph f double prime. I'll show you how to do that as well. If you graph f prime, what are you looking for? Where f prime is decreasing, aren't you? From negative 1.5 to 1.5. What if you graph f double prime? You're looking for where it is negative. You understand? All right, either that. x to the 4th minus 2x squared plus 1. I'm going to need help with that one. All right. All right. E to the x to the 4th. What was it? Rest of it?
Minus 2x squared plus 1.
Like that?
Yep.
Or, and then what's down?
Outside the exponent is minus 2.
Minus 2. Look good?
Mm-hmm.
There is f prime. We're looking for where f prime is doing what again? Decreasing. Let's change the window. Let's only look to where they're asking us. Menu, window settings, negative 1.5 to 1.5. We're looking for where the graph is decreasing. Well, this graph we're looking at is decreasing up until this minimum value. Then the graph increases. Then the graph decreases. You have to decide whether you're confident enough in the values where that happens. Do you know what I'm saying? Like, should I calculate some more values? Or can I say the graph's, it's decreasing from negative infinity up until this value, and then from like 0 down to this value. So you could even do that and say, well, it's about 1 maybe. And then here at negative 1 is where it stopped decreasing. Am I making any sense right now? Okay. So, and you look at the answers and decide whether it's worth your time to list more values. Well, I don't want to say negative infinity up until negative 1 because the window is only from negative 1.5. So negative 1.5 to negative 1. And then what did I say, 0 to 1? I might be confident enough at that point to say that answer. However, what if the next question that's similar isn't that cut and dry? I should probably calculate that minimum value. Menu, analyze graph, minimum. Go to the left of it, to the right of it, and you'll find out the x value where that occurs is negative 1. Let's do it again. Menu, analyze graph, minimum. I could also trace. It would just take a little longer to scroll over there. So I'm pretty sure this is at 0. That's not a 0. But hold on. I did minimum. Menu, analyze graph, minimum. That one's a positive 1. Menu, analyze graph, maximum to make sure that value is actually 0. And with rounding, yeah, it's 0. I don't know why it got that. Well, I don't know why it's off by a little bit, but it's all good. Good with that one? What if we chose to calculate graph the second derivative? Hit the tab button to bring up a new graphing window. What's the derivative I'm going to find? The derivative of f1. Here's a quick way to do it. Templates. I'm going to graph the derivative with respect to x of the f1 of x function. There's the derivative. I am looking for where the second derivative, the red graph, is negative. Do you remember that? Here's my chart. The blue graph is decreasing when the red graph is negative. Well, from negative 1.5 up until that value. And then the red graph is negative from 0 up until that same x value there. Does that make sense? How to look at it that other way? Awesome. I don't know if I've emphasized this enough or not, but the visual first and second derivative test is pretty highly tested on this. seen it quite a bit. 84. All right. 85. You guys did awesome. What was 85? So that another visual first derivative test, wasn't it? You're looking at the graph of f prime. You define a local max. Local max happens when f prime changes from positive to negative. Boom. There it is. All right. 86 didn't do. 87, not bad. Wait a minute. Another visual derivative test? Do you see my point here? Okay. 87, you guys, it was a 52%. All right. Well, might as well just run through it quickly. When is f concave down? You're looking at the graph of f double prime. F will be concave down when f double prime is negative. So when is the graph of f double prime negative? Negative, positive, negative. And I bet what they're trying to do is they're trying to get students to have their eyes deceive them, right? The graph of f is concave down. I should be looking for when something is going down, not necessarily. This is the graph of f double prime. So don't let your eyes deceive you. Go through that test. I've done it that way for a reason. F prime, f double prime. The correlation between those three layers will help you keep things straight on the test. All right? So from -2 to -1, and then from 1 to 3 is what I got. 87 is E. 88. Ooh, Tyler's problem. Nah, no, you had a James. You liked James' problem better. It's kind of getting old. You guys listen to me. Who wants to take the pen of power, and show us how to do this one? They simultaneously mentioned each other. I think they want to come up together. What do you guys think? One of these forever. How are they doing? You're taking control. I'll tell you. What's he looking at? I give up. Yeah. Okay. It's a triangle. Oh, Ricky and I were out at this tennis place. It's two triangles. It's an equal triangle. What's that? It's 6. 15. Yeah, do you want to hear it? It's not that great, but.
Do you come in as a
Nah.
Yeah, I give up.
I'm warning you, so I'm good. You can't just give up. Okay. Did you hear about the group of babies that formed a gang? They hang out in their crib.
I like that one.
Huh?
I like that one.
I think I threw it away. We're taking the trash. Ew. No, it's not worth it. Got Adam's wrist cracker back in there.
Oh man, I sure forget. Oh my god, we do the given and find thing. Given.
But we know what we're trying to find out, right? It's not going to help us.
What do you mean it's not gonna help us? This is the thing you told us to do. Are you leaving? That does not look good.
It does. It's fine. Okay, so what were we getting?
DXDY.
Yes.
Well, we're good.
You guys know the song from Another Ritz? It's a really old song.
It's a good song.
You know it?
Solid.
So I saw a meme that was pretty good. It was Vladimir Putin's face on a Ritz cracker.
I love that one.
Putin on the
He
Ritz.
said, I love that one.
Hey, bring I went to Subway.
It's like we're trying to find
Where's your head?
How's grandma doing?
Oh, she's good.
Man, I forget this. Is that the highlight shirt is 50 feet with the radar versus shadow? What's this?
This is the rate at which he's walking.
He's walking 4 feet per second. Why'd you write 4.5?
No idea.
Dude, this is like race car. Genius. You? What'd you do?
At this point, it's very race fans.
This is I hate you.
Come on, tell me what you want to do.
You will wait to find your ID.
I have to find which is the shadows.
I give up.
I can't just forget.
Hey Logan, I'm calling a friend. I don't remember how to do this. We guessed. We guessed on this.
How old are you in it?
Hey, what are you guys shaking your head for? What's going on? Cole.
Come on.
Come
on.
Don't want to leave it forever. I was out cold and he called me up. Hey, Tony.
We don't know how to do it. What we find.
We got some geometry students out here if you need some ratio help.
I don't remember how to do any of this.
Should we help them out?
No, I like the struggle.
Yeah, this is good.
Give me a second.
Long, guys.
This is how I learn under pressure. True. Rereading the question 15 times isn't gonna help.
But maybe one of these times I'll get it. What are you doing?
With arrows.
Yeah, it does.
We have to answer part B first. Ain't no part B.
That's pretty good.
I mean,
Oh, it's the arrow.
They just merged together.
You see it?
We both saw the same thing.
Huh?
We have a hint.
There's no cheating on the AP test.
This isn't cheating.
there's plenty of cheating on AP tests.
What are you crossing that? What's that thing?
No, I'm changing it to this thing.
You got that for
15, 6. Here to here is 4. But it's like 4 prime, basically. It's a derivative. I'm answering this, not you. Whoa. What? Continue. What you were saying.
Okay, so imagine it's a ratio, right? Should we find this?
Cold outside, but it's getting pretty hot in here.
Write $2.
Detention? You don't recognize these? I guess you
Throw 'em
guys
at
being detention 5 days a week. Yours truly. We spent some quality time together.
So,
Actually,
hey, shut up.
it's
Okay, so I'm not gonna have it in the morning.
It's the best, dude.
Really?
I can't talk to you because I'm being recorded right now.
So,
But
it's time.
teachers have to get here. Our contracted time to get here is like maybe 7:15.
no, you're wrong.
So typically I used to do like academic lab. So like
It's crazy.
each period I have to walk all the way down to the LOC.
I had like 6 points.
One kid a week.
Oh, we take like 6 off us. So you get 6, what is this, like 9? That's 6 tall.
That was my duty.
I don't know.
Study
Those
hall
were
or
numbers,
proc
man.
or something, right?
It's a lot of numbers and don't do anything.
Well, if I did more attention, I get here at 7, which I always get here at 6:45 anyway. Get here at 7. Morning detention, 7 to 7:30. Then I get to leave after 7 period. Because that's my duty. So I do it before school. Then I get to leave after 7 period.
I don't know.
I didn't even know I had more.
I just get to sit in my own room.
Him.
Kids come in, they do their detention, serve their time.
Give me a second,
I
I'll
don't
be
have to
back.
do anything other than put their names down and
Going. Don't go to him. What's going on?
You guys giving up?
No, I'm researching.
Want to be cold? Okay.
I don't play, but I make the smaller.
That's what I just did.
16.
You do the smaller triangle. What? Yeah, because that's 64 for each side, right?
Yeah.
50%, right? So I did that ratio.
Bro, I'm pretty sure.
9, 4.
Oh my
We got 2 miles. 5 minutes. No, but I like that where I was going. I did.
It feels right?
This has something to do with it.
No, you're right. It does. Because that's this plus this, which relates to this plus this. But no, it doesn't. It's just this and this. 6 over y is equal to 15. Yeah, that's true. But that x is actually just 4. Hold on to your pen harder, man. This is actually 4.
Why is that? How's that for?
What do you mean, how's that 4? What is that?
You guys have a trigonometer?
It's the same thing. Trust me, it's the same thing. It's the rate. We're trying to find the rate. This is this, as this is this. It's the ratios.
So you got y right there, x right there, plus 4. Oh, that's good. Okay.
Minus 6 minus 9. It's y plus 4. 24 divided by 9.
Oh, I haven't seen this.
Oh, he's. Man, why am I trying to add him? What's this? We have the answer. We literally have the answer. Stop writing. Stop it. You're gross. Stop it. Stop. You're gross.
That makes sense.
No.
Where is it?
Whoa, dude. What are you, the whiteboard creator?
Yeah, man.
This is gross.
Yeah. Okay. Let's check this out.
No, what are you doing? Don't erase all that.
Why not?
Because that's all of our work. Actually, you can erase it all. I'm.
How did you do your
Huh?
How did you do your drive activity?
Yeah.
I trust you. It's okay.
We'll figure it out. I just erased it so it's neater now.
Yeah.
You ready?
Oh, I'm ready. Can you explain it?
Yeah.
Did you do your driving activity?
You're gross, man. Stop. The triangles are
Did you do your
proportional.
driving activity?
What?
Did you do your driving activity?
Yes.
Why do you say it like that?
How far did you go?
How about 2 miles?
Where'd you go?
My grandma's house.
All right, go ahead. Quickly explain. Explain quickly.
They're proportional. So when this height's 15 and its x value is 4 for this. That's the rate at which this is changing right now. Is 4. So you could say this 15 is the 4 as this 6 is to this y. We'll work on that value y. So then when you write it down, it's 15 over 4 plus y is equal to the smaller triangle, which is 6 over y. And then cross multiply, you get 24 plus 6y is equal to 15y. And then algebra. 9y is to 24. 24 divided by 9 is equal to y. That's a y. And b.
You didn't do any calculus.
Derivative, it like up
When?
there. Because this would be x, but it's not x because it's 4, because that's 4 prime.
Calculus was done for us.
All right, can we agree on something?
Oh no.
Can we agree on something? It took them way too long to do this problem.
Yes.
Okay, I'm just kidding.
I was asking around, nobody else did.
All right. For next time, I hope it doesn't I hope you don't see this on the AP test and then you start laughing and get distracted for a long time because you remember this day. Oh, remember the time Lane and Tyler tried to do that problem? Okay, here's what you should remember. When it says, what is the rate at which the person's shadow is lengthening, you should look straight at the picture and say, this is the person's shadow. Whatever I call that, I want dy dt, or if you call that m, whatever, I don't know. You want that rate. That should be the letter, the variable, that you have involved in your proportion, correct? Yes? Okay. So, did you guys called this x, you said?
Yeah.
So the proportion should be 15 over x plus y equals 6 over y. So 15y equals 6x plus 6y. And so 9y what's that, 2/3? 2/3 x? Yes? I would recommend doing it this way, okay? Aren't we looking for a dy dt? That's 2/3 dx dt. You guys agree with that? Yes? 2/3 dx dt. Do we have dx dt? We have a person whose height is 6 blah, 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 is walking away from the base of a streetlight at a rate of 4 feet per second. They're walking away from the streetlight at 4 feet per second. It's increasing. The distance is increasing, so it's a positive 4. What's 4 times 2? 4 times 2/3. 8/3, which is 2.6 repeating, right? So I would be careful there. You plugged in 4 right there. Is x really 4 though? It's the x dt, isn't it?
Yeah.
So I would just be really careful there. You need a pass or you good? Right. So I'd probably set it up this way and take the derivative and then plug in the values after you've taken the derivative, just to not freeze it in time. All right. I didn't give you guys. Did I give you guys any? Solid 21%. Probably don't need to go over it. Okay. Warning, alert. They're trying to trick you. Okay. Anytime they give you a table, and they ask you, which of the following, oh my gosh, which of the following must be true? Your Mr. Westfall senses should be tingling. Okay? You should be on high alert. That was kind of a weird thing to say. Pretend I didn't say it. All right? Which of the following must be true? What graph are we looking at? X, comma, F prime. All right, here we go. Let f be a polynomial function with the values of f prime at selected values of given in the table above. Okay. Which of the following must be true? The graph of f is concave up. Man, we're doing this again? Well, f will be concave up when f primes are good, increasing, which meant f double primes were positive. Okay. Well, we're looking at f prime, kind of. Are f primes increasing? Well, I go from 3 to 1. That's decreasing. I go from 1 to 4. That's increasing. 4 to 7, increasing. And then 7 to 5, decreasing. Okay. From negative 2 to 6, is the graph concave up? What word? I guess what would be more clear wording in there? I probably would have said exclusively concave up. Is it concave up the whole time? No, it was concave down when f prime was decreasing, right? You guys are kind of quiet. Are these words making sense? Okay. All right. So I don't really like that one. B, and it says which of the following must be true. All right. B, the graph has at least 2 points of inflection. When does that point of inflection occur? When f double prime changes sign. But wait a minute, we're not looking at f double prime. Please listen carefully. F double prime will change sign. We need to look at this layer because that's the one we're talking about. That's the one we're given information about. F double prime will change sign when f prime does what? Changes from increasing to decreasing or vice versa, right? You with me? So what are we looking for? Where f prime changes direction. Good. Ready? 3 to 1. What's happening there? Decreasing. 1 to 4. What just happened? Can I interpret that as there is a direction change in f prime? But I didn't see it. By the intermediate value theorem, there must have been a point where f prime changed from decreasing to increasing. Do you agree? In other words, f double prime must have changed sign. Somewhere on the interval from here to here. Do you agree? Be honest with me. I need your help. Do you agree? Okay. Do I know where it happened? No. 3. Is this the lowest point on f prime? Because we're looking for a change in direction. Okay, I knew f prime was going down. I'm looking at the graph of f prime, not f. F prime is going down, and f prime is going up. Is 1 the lowest point on f prime? It's the lowest point we can see. But what about at point 1? At point 1, could it have been negative 7? It could have been. Could it have been negative 100? It could have been. Somewhere, I don't know where, it goes back up to 4. Could there have been 5 changes in direction from negative 2 to 3? Yeah, there could have been. I know there's at least 1 by the intermediate value theorem. You with me? 1 change in direction means 1 point of inflection so far. With me? Let's keep going. All right, go 3 to 1 to 4 to 7 to 5. What just happened on this interval? F prime changed from increasing to decreasing. I don't know where though. But by the intermediate value theorem, F prime had to change direction somewhere on that interval. You with me? There's another point of inflection. Do you agree? I like that one so far. All right. When is F going to be increasing? F will be increasing when F prime is positive. I bet you guys put that. No offense. C. Yeah, most of you, if you got it wrong, answered C. Let's just own it, okay, and move on. Whether you got it right or not, doesn't matter. What do you think the people who answered letter C were thinking of? How did they fall into the trap? Because Mr. Westphal, F prime, positive, 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 F prime's always positive. Dom, what do you think? Yeah, we don't know the F primes between. Remember how I said F prime could have been -7 on the interval? And what did they say? Must be true. Must be true. They're trying to trick you. They're trying to trick you. They're trying to test your understanding of the intermediate value theorem. But it's tricky. It's a tricky question. Do you agree that doesn't have to be true? F has no critical points. Well, a critical point happens when the derivative equals 0. I don't see any times the derivative equals 0. Again, between values, F prime could have equaled 0, right? F has at least 2 relative extrema. Well, F will have extrema when F prime equals 0 and changes sign, right? Extrema, positive derivative, negative derivative. Extrema, right? Why is that one out? Dom? Right, but the Dom, 3 down to 1 and then up to 4, F prime went from 3 to 1 to 4. That was a minimum on F prime, wasn't it? That didn't mean that F has extrema there. Do you agree? You see the difference? So we don't see any, we are not guaranteed any times where F prime equals 0. When do you have a question on that one? You good?
I thought I got it.
Okay. And was that the last one? You guys didn't do 92, I don't think, right? All right, let's start on number 4. Oh, stop it. Okay, help me out. You guys said 4, A, B, C? A, B, C. So your free response wasn't out of 9. It was out of 6. All right. The main thing for the last 5 minutes I'm going to be doing is teaching you guys how to score these. I think I had you score them, but I want to make sure you understand. F prime of x. It's either right or wrong for this one. Okay. If you didn't do the chain rule, no points for part A. It said F prime of x. All of it needs to be correct. Okay. Now, could it have been left in this version? Yes, you could have left it in that version. I never let you do it, but you could have. All right? 2 points for that part. B, write an equation for the tangent line. How many of you, as annoying as I am when I say this every time, how many of you were thinking I need a slope and a point? When you heard equation of the tangent line, I need a slope and a point. Good. Where do you get the slope? Well, F prime. Where do you get the point? Well, at -3, you want to plug it into here, right? -3 squared is 9. 25 minus 9. 16 squared of 16 is 4. Plus or minus 4 or just 4? Just 4. So -3, 4 was your point of tangency, and your slope of your tangent line. The slope of your tangent line, you get to plug -3 into this derivative, and you get 3/4, I believe. All right, now to help you out with the scoring of this, did you see how they wrote it kind of in slope-intercept form? What if you put y, where am I? Y minus 4 equals 3/4 times x plus 3. You will get full credit. Okay? They awarded you 1 point for the slope, and then 1 point for the line. The equation of the tangent line has a complete answer. It doesn't matter what form you put it in, as long as it's equivalent to that. Are you with me? Do you understand how they scored that one? Okay. By the time we get to the test, you guys are you're gonna read a problem, like on the practice test. We're gonna kind of condition you guys to read the problem and look for how many points are going to be on, like you'll be able to kind of anticipate how many points are in each section and what your checkpoints are to get those points, all right, as we get through these. All right, part C. Is G continuous at -3? Use the definition of continuity to explain your answer. Do you guys? What is the definition of continuity for G of x? The limit of G of x as x approaches C equals. You have to know this. It's been a long time. You have to know this. I put it on multiple quizzes, multiple tests, exams. G of. This is an error. Huh? G of C. What was the limit as x goes to C? Ready? Limit. Oh, wait a minute. It could have been open, couldn't it? Limit. Limit is C. Sorry. Limit is something. You can sit on my desk. Thank you. What has to happen for it to be continuous? That was the sound effect for filling in the open circle. Has to equal G of C, right? Here's C. There's G of C. The limit has to equal the function output for it to be continuous. So at -3, you have to find G of -3. All right. And then show that the limit from, what's the limit from the left? Well, what's f of -3? What's the limit as x goes to -3 from the left? Isn't it f of -3? What's f of -3? Isn't it 4? What's the limit from the right? 4. Open circle, closed circle? Well, one of them was closed, so it fills it in, right? Therefore, G is continuous. There's your definition right there. All right, have a wonderful evening.
We have to write that equation like out like that number. So we explain like it equals 4 on both sides. Type of thing.
You need to include what I wrote in some form, like mathematically. They call it notational fluency. Okay. You have to show that you know, show that you're plugging this in right here.
Good one, Matt. It's a good one.